What's up, everybody out there in YouTube land and video watching land? This is Mr. Myasis, and I am going over. Oh, what was this? This was 3.6. This is section 3.6 for BC calculus, integration. So antiderivatives. Derivatives. I can't spell very good with this pad here, but hey, do the best we can here. So antiderivatives is basically going backwards, guys. When we did derivatives, we found f prime. Antiderivatives, we are actually doing finding f using f prime. If you're in my class, I would like you to do examples 1 through 3 on your own. Go through each of those steps before getting to this video. So if you're watching this video, you're in my class, pause it right now, go back, do that first page, which is on page 77 of our workbook, and then we'll move on from here. So these are some integration rules. Now we call it an integrand, an integral. This is basically another word for an antiderivative. But we have the integral power rule, we have the integral constant rule, we have the integral scalar multiple rule. Basically just means that we don't really have to factor out of the integral. We could just do in there with the number. We have the sum rule here, which basically means that we can do the integral all at once. We don't have to separate it all out. And then we've got some trig rules that are important that you know. So I'm going to go and go through these here and write these trig rules out. Just think to yourself, what do I need to take the derivative of to get cosine x? And that's going to be sine x plus c. And I got to put the plus c there is because, as you'll see, get it? As you'll see, we need to put a constant there because if we take the derivative of this constant, we get 0. And so we're going to end up with that cosine, right? If we took the derivative of sine x plus c, we would end up with cosine because this derivative of the constant would drop out. So when we're taking the antiderivative, the integral, we need to put that c in there. All right, so what would we need to take the derivative of to get sine x? Well, that's going to be negative cosine x, right? Because the derivative cosine is negative sine, so we need to put that little negative in there. So here, you probably figured this out. This is going to be tangent plus c. This is going to be negative cotangent plus c. This is going to be secant plus c. And this could be negative cosecant plus c. All right, so let's do a few examples here. I don't know why I've got these little dots here. Let's do a couple examples. So the integral of x cubed. So we're going to use a power rule for integrals, and the power rule for integrals basically says, look, add 1, divide by that number. Add 1 to the power, divide by that number. So we're going to add 1 to the power. 3 plus 1 is 4. Divide by that number, plus c. That's it. That's all there is to that one. So this is a constant. So this is like x to the 0, right? So 2x to the 1, divide by 1, plus c. There we go. We got our, and we're using the constant rule right there. Okay, so this one, we're just going to do it all together. So we're going to do this one first, and then we're going to do this one next. So t to the 4th, we're going to add 1. Divide by that number. Boom. Plus, the constant rule is 2t. 2t fruity plus c. All right, there we got our antiderivative. There's our integral. Okay, so what about this one? This has got a little polynomial here. Okay, so we're going to take 2y. We're going to y plus 2, the squared plus 1 is cubed. Divide by that number, 3, plus 4y squared, divide by 2, plus y, plus c. All right, you can leave it like that, or if you want, and it's really bugging you that the 4 over 2 is not 2, y squared, you can do that. Okay, plus c. And there you go. Those are some examples, and I'll be back in another video for more examples using these properties, these rules of antiderivatives. Okay, we'll talk to you soon, guys. Bye-bye.